All right, welcome back everybody. My name is Dustin, and in the last video, we created the log display so we can actually see the errors or the logs inside of the editor rather than in the console. And in this video, we're going to tweak our scene display. Currently, we just play the game right away when we start the editor. This is not something that we really want to be doing. So we're going to be slowly starting to add the ability to load scenes rather than just starting the game with the scene already playing or the game already playing, okay? We're going to have to change this a few times as the editor progresses. However, I do believe that this will help us a lot. Okay, so the first thing we're going to want to do is to add a couple more variables to our scene display. So let's close this and start that now. Okay, so in our scene display, we're going to want to add two Boolean flags, one for playing the scene and one for if the scene is already loaded. Okay, so we'll go bool mb play scene, and then we'll also have mb scene loaded. Cool. Now we're also going to want to create two private functions here. So let's say private. They're going to be void load scene and void unload scene. Void unload scene. Now again, we will be changing a lot of this stuff later on as we actually develop our scenes, because right now we don't have any scenes. If we look at our code here in our editor, we just have the editor and displays. Eventually we're going to have another one for scenes, scene management, scene hierarchy, but we'll get into that later on. Right now we just don't want to actually load all of our code right away. We want to add a play and a stop button to the game. So that's what we're going to do. And we can create these. And before we go with this, let's go back over here. And I want to add another virtual function for updating our display. So let's say virtual void update. And this is going to be an override. Now, we haven't created this yet. It doesn't exist as part of our iDisplay. So we need to go add that in there. So let's do that. So we go to iDisplay. And this one's not going to be pure. It's going to be virtual void update. And we're just going to have so it won't do anything. That doesn't mean we have to implement it, but that means that we can implement it and we can override it. All right, so let's go back to our scene display. Let's make this function. So now on the load scene, currently, so let's go here, mb play scene. Let's actually make this false. And then mb scene loaded, we'll also make that false. Cool. So in our load scene, in reality, right now we're loading everything in our application. So if we go to our application, we're creating all this stuff in here, all up here in our initialization function. We're adding all this stuff in. Well, some things we don't need, like the Lewis state, we need that to not necessarily be loaded here. Like we can do that here, but we're going to want to actually registering our Lua bindings and all this stuff outside of this. It needs to be registered every time that we have our Lua. Does that make sense? So the Lua state will hold all these things, but we don't want to load it right away. All this, we actually want to pull this all out and put it into our load function. So let's take this. We're going to have a bunch of errors. It's going to take a few minutes to get this to go correct. So paste that in there for now. Let's add some includes. So we're going to need include. We're going to want the main registry. ECS. Now I want the main registry. And then we're going to want to have our systems. We're going to want the script system, physics system, animation system. So include core systems, animation system, physics system. Then we're also going to want the script system. And we might as well get our core globals as well. Core for utilities, core engine data. And you're going to need, put this all up here. It should probably be in these. Why doesn't it like that? Probably call this something else. Scripting system, not script system. Cool. We're going to need our logger. We're going to need our music player. Sounds, music player. We need our sound player. Sound player. sound effects player. And I think we're going to need our box2D wrappers as well. So let's say physics, box2D wrappers. Cool. All right. I think that's everything we need right now. So we see here our scene will have a registry, and we're going to want to change this here. It's not going to be dereferenced any longer. And then we're going to want to get the scripting system and get Lua from the registry. So auto reference Lua is equal to m registry get context std shared pointer to the soul state. And then we want to go auto reference script system is equal to m registry dot get context std shared pointer to the script system. Cool. That's not going to work like that. So let's use a namespace up here. So using namespace Scion for system. Let's fix this real quick. Scripting system. I keep messing that up. Cool. And this doesn't need to return false here. We can just return if that fails. And before we do any of this, we actually want to make sure that we're opening our libraries. So let's actually go steal that from application. We don't need to open it there. So where do we put that? So we still want to add Lua to the registry, but we don't want to do any of this opening stuff. We can actually take this out here. We can leave that. Cool. As long as there's nowhere else this is being used. Cool, that's good. So let's take that and put it into our scene display. We'll do that here. Cool. So then we want to say that the scene was loaded, MB scene loaded is equal to true, and MB play scene is equal to true. Because you're only going to be loading this when you hit a play button that we're going to create later. Also, right here on our unload scene, we're going to want to say MB play scene is equal to false because there's going to be a stop button. Then we're going to say MB scene loaded is also equal to false. And then we're going to want to clear our registry. So M registry dot get registry, not get context, get registry. And we're going to want to clear the registry. And then after that, we're going to want to reset our Lua state, okay? Because we don't want to have anything in it. So we'll just reset the pointer. So we'll go auto reference Lua is equal to m registry dot get context of the std shared pointer soul state. So we'll get that context and then we'll say Lua dot reset. Cool. And then if we do have the music player, all that will be in the main registry. So we want to go auto reference main registry is equal to the main registry macro that we created. Then we want to say main registry dot get music player, and then we just want to call stop because we want to stop the music if the scene's not running. Stop music, stop any sounds that are playing. If the scene's not running, this stuff doesn't need to be played. Copy this line down, get sound player, stop. And this we have to set the channel, and we want to stop all channels, so we use -1. Now, since we're resetting Lua here, we actually need to check on our load if Lua is null or not. So if not Lua, we want to go Lua is equal to std make shared soul state. Cool. That's it. All right, so now we have our load and our unload. We can actually start to adjust our draw function here. But before we start doing the adjust here, let's actually go to the update function and add in what we need to update there. So in the update function, we can go if not MB play scene. We can just return. because if we're not playing the scene, we don't need to update anything. Okay, so now we can just go auto reference main registry is equal to our main registry. And we're also going to want to get the core engine data or the core global function. So let's go to that real fast. Let's go to our core engine data, see if this will take us there. Cool. And right now, the core engine data, if you've been following all along, it's actually just a singleton where we get the instance. So I want to do the same thing. Instead of calling this get instance every time, I just want to have something similar to what we did with the main registry and just create a definition so we get a macro. So define, and we'll call this core globals. And we'll say Scion core engine data get instance. Cool. So now we have this core globals that will call this for us. Cool. So let's go back to scene display, and we'll actually do the same thing right here. We'll get the core engine data or the core global. So auto reference core globals is equal to core globals. Awesome. And before we keep going, let's actually go back to our application.cpp, go to the update function, and we need to grab all this stuff. So right here is what's called the engine data. Well, we'll just keep this here, keep the update delta time here, so it's always updating delta time. Then we're going to need all these things right here. This doesn't need to be in here any longer. We can move this here, take that out. All that can go into our scene display. I'll just paste it here. And we're going to have to change this accordingly. M registry. Oops. So right here, we had all this hard coded. Now this here, instead of doing the division each time, we can actually make this into a const expr. And for now, we'll just place it in this file. We'll move it somewhere else later. But for now, we can just say const expr float, and we'll just call that 1/60, and that's just going to be equal to 1.f divided by 60. And this should be done at compile time and just put in wherever we need it. And we'll take this and get rid of this here. Cool. And we should have core engine or core globals for these. So this would be, let's see what that would be. That would be the velocity iterations, core globals dot get velocity iteration, and also core globals dot get position iteration. Now I'm not sure what we have these defaulting to, so we can take a look. So right there, let's go to our constructor, and we have those defaulting to 8 and 10. I don't know what we had those at. That can stay there for now, and we'll change it if we need to later. Cool. So back in the scene display, so we're updating, we're doing our step here for our physics world, and we can actually, I think we can just clear the forces. So we'll just say P physics world, and we can say clear forces here, just in case. I'm not sure if that's necessary, but we'll do it anyway. Take it out if we need to. Okay, up here, and that's all we need to do. So we've moved this all here, and that's all we really need the core globals to. Now, if we wanted to, or we can actually wrap this. This should actually be wrapped. Let's use our, so go if we have our core globals, and then we can say is physics enabled, and only do this stuff here if physics is enabled. All right, so we cleaned up our update function a bit. Let's go back to application. Yeah, so now we're just updating the camera. We could probably move that there as well. We don't necessarily need this particular camera to be updated here. And actually, that's exactly what we'll do. So let's take this, go back to our scene display. And if we're not running this, we don't really need to update the camera. We'll do that here. Actually, we'll do that before the script. We'll do that right here. get our camera, MP registry, get contact 2D camera. So we're gonna have to add this in top so it knows where the camera is. And we'll do that within our rendering. So include rendering 4, I believe, and camera 2D. Awesome. So it should know what that is by now. So now we need to actually make some changing to our draw function. And we can do that. So like I said before, we're going to want to have two different buttons. The play scene and the stop scene button. One will load and the other will unload. Okay. So we're going to want to have two new textures for that. So first thing we're going to want to do is get the main registry. So we're going to go auto main registry is equal to main registry. Unless we're already getting it in here somewhere. I don't think we are. No, we're not. Cool. So we're getting the main registry. And then I want to get the asset manager. So auto reference asset manager. It's equal to main registry dot get asset manager. And then we're going to have to get two new textures here. The play button. So we'll go auto p play texture is equal to asset manager dot get texture. So we don't know what the asset manager is, so we have to come up here and add that in. Include resource for resources asset manager. So now that we have the asset manager, we can go here and asset manager dot get texture, and we're going to want to get the play button. And we're going to want to get a stop button as well. And we'll call this the stop texture. The only problem is these both don't exist right now. And we don't want to actually have to load these files or hold on to these assets as a texture. We want to actually have these embedded in our engine. Okay. So in order to do that, we need to be able to load the files or load the textures from memory. Now we did start looking into that previously, but we never actually finished it. So let's go to our asset manager. I'm not sure if we have it there. So let's go to asset manager, Scion, resources, asset manager.cpp, and we'll open up the H file as well. Asset manager.h. It looks like we started it. We started the add texture from memory function, and looks like it's somewhat filled out here, and then create from memory. So we're basically done. We got a lot of footing done already. But if we go to create from memory, we have this to do. We never actually did this. So we want to do this now. Okay. We can get rid of this to do. And loading from memory, we basically want to do the same thing. However, we need to add a new function in, and we'll call this load texture from memory. So we basically want to do all of this stuff here. Grab all of this. We can grab all this here, this create stuff. And actually, we can grab all this and we'll just change it accordingly. So grab this and paste this here. Cool. And we can get rid of this entire switch statement here, all of that. And we want to create a new function, and we're going to call it load texture from memory. Okay. And that's going to take in the image data that we'll be providing. And it's going to take in the length. And it's also going to take in the ID, the width, the height, and if it's blended or not. So let's go make that function now. Cool. We can actually just copy this and go back to texture loader.h, and we'll put that up here as another static bool function. And the image data is going to be const unsigned char. Basically the same as what you see here. This is going to be size t. We can copy this. So put that there on unsigned char pointer, sorry. Size t length. Then the ID is going to be GLUint ID, just like this. All these are actually going to be the same, so we can actually copy all of that. Yeah, we can copy all of that. And just paste this in here. Cool. Really, the only thing that's changing is the image data and the length. Okay, so then we can create a new function. And the load from memory is going to be a little bit different. We're going to need to use soil still. So we'll say ID is equal to soil load OGL texture from memory. And we need the image data. And we need the length. Then I want to say soil load RGBA and soil create new ID. And then we're just going to send in null for the flags right now. We may change that later for inverting or whatever. But right now, that's all I need. So right here, I need to go if ID is equal to 0. Then I want to say Scion error failed to load texture from memory. Because it must not have worked if the ID came back as 0. And then we can return false. Cool. And after we've loaded it from memory, we can actually just maybe copy all of this stuff here. We don't need text image 2D because that would have already been done for us. But we do need this here. So we just take that, paste this, where's our function, sorry. Paste this here. And then just go through. Cool. I think that's all we need to do. And we just gotta go down and fix this here or make shared. And this one for our type, we'll just say, is it blended? So we'll say blended. So we'll just use a ternary. And if it's blended, it'll just be texture, texture type, blended. Else, it's going to be pixel, texture, texture type, pixel. And it's not going to have a path because we loaded this from memory. So we can just say, instead of texture path, we'll just say from memory. Actually, we'll just leave that in. Cool. All right, and that's it. So if that worked, we will actually be returning a proper pointer. If not, we'll end up with a null pointer. Okay, so now that we can load from memory, we need to actually have those files in memory, kind of like we did our default fonts. But we're not going to add these to the core because it might not be needed outside the editor. So we'll actually add these in the editor. And here in the editor, we can create a new folder. So add new folder, and we'll say utilities. Utilities. Add that in, and inside of utilities, we'll add a new file. And the new file is going to be editor textures. Editor textures.h. Cool. And it wants to add to our script list. And short, that's where I want it. We'll just say apply. And then right now I already have it queued up. Now you could use other ones. I showed you before how we can use the binary converter application to create unsigned char arrays. And I did that with this particular play button. And I also did it with a stop button. Now these are just simple textures that I created using Sprite. And it's basically just a triangle with a box around it. And this one is a square with a box around it as well. And I just extracted the data. Cool. So now we should have these. Now we need to load them. And with that, we can load that from our application. So whenever we start the application, we want to load these textures. So if we go to our application.h, in here, anywhere in here, doesn't matter. We can just say bool. Well, we have our load shaders, so we'll do it here. So bool load editor textures. Cool. And let's make this. Cool. In our load, we're going to need to get the asset manager and the registry. So we might as well just copy these two lines. Here, paste. And we're going to need to get the editor textures. Let's close this. Let's add that in. So that could just be here. So include editor utilities editor textures. And let's go back down to the load, editor textures. And we're going to want to say if not asset manager load texture or add texture from memory, sorry. And we're going to want to say play button. At least that's what we called it. Hold on. Let's go back in my scene display. What do I want to call it? Yeah, play button and stop button. We want to load those two editor textures. Okay, back to that. So play button, and that's going to take the play button. That is the car array that we created. And it's going to take, I believe we have, okay, so it doesn't look like I created the variables for these ones. So since I didn't create the variable, we can actually we can change the data accordingly. We can say, not an asset manager here, we can say size of play button divided by size of play button at 0. Cool. That's going to be our length. And we want this to be pixel art, so we can just leave it. Awesome. So if that failed, we want to have an error. So we just want to say Scion error failed to load texture play button from memory. And then return false. And we're going to copy this and do the same thing for stop button. Change this to stop. Change this to stop. 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 Cool. Fail to load stop button from memory. If we get to here, we return true. Okay, so even though, and we can take this and we want to put this into our initialization. So load shaders, create displays, we can do this here. So if not, just copy this. So we didn't fail to load shaders, we failed to load the editor textures. Editor textures. Cool. If we run this is actually going to fail anyway because there's something wrong with our soil that we'll go over in a minute. So let's try to run it just to show you. Awesome. Okay, cool. Right here. And it failed exactly where I wanted it to fail. So it's saying right here that this is an access violation reading location. That's because these particular capabilities do not exist in the GLAD that we're using, in the core that we're using OpenGL core, as this stuff isn't here anymore. So we need to make some changes here to have it work so we can load it from memory. So that stuff was deprecated and removed from core. So we need to add in some changes that worked for me. They may not be the right way to do it, but it's what I had to do. Okay, so let's just stop this. And we already have this open. Let's go up to the top here. Yeah, so see in the include GL, right here, the stuff doesn't exist anymore. So what I want to do is actually get our GLAD into this. Okay, if we can, so include glad.h. As soon as we did that, you see here, we ended up with some red. That's because this stuff doesn't exist anymore in the GLAD core. So we actually have to make changes to those as well. So GL luminance has actually been changed now. And instead of GL luminance, we're going to use GL red. Instead of GL luminance alpha, we're going to use GL RG. Cool. And then we'll go down here and do the same thing. So GL clamp is also deprecated. Instead of GL clamp, we need to use GL clamp to edge. Okay? And I believe that's the same thing down here. Yeah, GL clamp to edge. Cool. All right. But we're still not done. Still not fixed. Because if we run it again, it'll fail in the same spot because we haven't handled this here, the query endpot capability. we need to adjust this because the get string and GL extensions doesn't work anymore. So we actually want to change that. We're just going to keep this here, comment out all of this. Matter of fact, let's just copy this line. Actually, let's comment the whole lot out. Okay. Or, yeah, we'll comment the whole thing out, copy it, put it above. We'll keep this here and comment it out. And we'll just say the below way has been deprecated in Open GL 3+4. Cool. And we need to make some changes here. So we'll keep this. We'll just get rid of all of this for now. Okay. And we're going to say GL int n and I. And we're going to say GL get integer v GL num extensions. So now what we're doing is we're getting the number of extensions and we are going to hold it in the n value. Okay. So number, you could say num or index, right? And sorry, and then we want to say for I equals to 0, I is less than n, I plus plus, and we want to go through each of the values, say if, and we're going to take in the GL get string I, get extensions at I, to char const pointer, GL get string I, GL extensions at I. Then we'll say GL ARB texture non-power of 2. And then we want to say is not equal to null. So we're looking for this here. So we're checking these to see if this is in it. And if it is there, we want to return soil capability present. Okay. And if it makes it outside of here, we want to say return soil capability none. So let the user know if we can do non-power of 2 textures or not. That's basically what we're doing here. So we're checking, going through all the extensions and checking to see if they have this in there, if this extension's there. If this extension is there, we say yes, we can. If not, we return this. Okay. And if we run now, it should work for us, unless I made a mistake, which is possible. Yay! Cool. So we still have all these errors here, and that's fine. And we'll deal with that, but we're loading our textures in, at least I believe we are. Let's check at the bottom, doesn't say. Cool. So let's go back into our scene display and keep going from here. So now that we have our textures, we want to, if our image buttons, so let's just go if I am GUI image button, and we're going to say, inside the image button, I'm going to say, it needs the texture. So what texture are we sending in? And we need to cast it to IM texture ID. Then I want to say P play texture get ID. So we're sending in the GL texture. Then I want to have how big I want it to be. How big do I want the button to be? IM vec2 size. And I want to say IM vec2. Then we're going to cast float the P play texture dot get width, and get width returns, or that says get height right now, but get width returns a const int. So we'll say get width. And also, I know it's going to be too big at that size, so I want to say times 0.25f. That's for the 1. Copy this line down, change it to get height. Cool. And I don't need to add anything else in. Like these here are the UVs and the frame padding. That's fine. We'll just leave it as is. Okay. So we have that there. And then I want to say inside of this, so we have our I am GUI button. So right outside, I want to say and not MB scene loaded. Okay. That is true. We go into here. So KG, get that all set up nice. Cool. And if we push the button, that's when we call our load scene. Load. All right. And we want to kind of do the same thing for our stop button. So let's just copy the whole lot. Paste that in. Change this from play texture to stop texture. And instead of scene not loaded, we want the scene to be loaded. Cool. And then this is where we call unload scene. All right. Right now, these will just be drawn one after the other. Well, we don't want to do that. I actually want to have it in the same line. So I want to say right here, I am GUI, same line. Cool. And let's just try to run it, see if it does what I want. And I don't see, let's see if it's even getting called. So the texture's there. Yeah, so our texture didn't work. So you see the M width negatives. This didn't work, so I did something wrong. So let's go back to our load texture from memory. I must have missed something. So let's go texture loader. Yeah, I definitely did miss something. So we're loading it from memory and we're sending in our width and our height, but we're not doing anything with it. And we also could set our channels and check our channels, but it's not necessary. But right here, after we get here, we actually need to get the width and height data. So we need to get the width and height data from the texture. Okay. So then we need to go GL. It's already bound probably, but we'll just do it again anyway. GL bind texture, and then GL texture 2D, and that's our ID. Then we want to say GL get texture level parameter IV, and take in the ID, and we want to go 0. And I want to say GL texture width, and then send it takes in a pointer, and that would be the width. Cool. I'm going to copy this down and for height. So the same thing. Cool. That should work for us now. And we shall run it. And we'll go to scene display, get rid of this breakpoint. Cool. Awesome. There's our buttons. And if I hit load scene, cool, it loads our scene for us. But it looks like something else isn't working, and that's fine. We'll have to handle that. Stop scene, and we're breaking stuff. And that's fine. And it probably makes sense why it wasn't working. That's because we're not updating anymore. We moved all the update stuff, but we're never calling it again. So we actually have to loop through our displays and update them in the application. So let's go to the application here. And in our update, which is here now, there's not much going on anymore. But now we actually have to get the display holder. So we want to go auto reference main registry is equal to main registry. Then we want to get the display holder. Display holder is equal to main registry dot get context, and that's std shared pointer to the display holder. And once we have the display holder, we can loop through all the displays and call the update function. So for const auto reference p display display folder displays. And from there, we can go P display. All right. Now that should do our updating for us, and we'll figure out why it crashed after. So let's just make sure it's updating still. Cool, so nothing was loaded. So yeah, right here it's saying script has not been loaded, script has not been loaded. That's fine, let's just run it. Cool, so the script's loaded. Let's go to the top of our errors. Loaded all of our textures and run. Cool, so our play button's working. And if we go to stop, it'll probably crash again, and it does. Cool. So we're gonna have to do something about that. Let's just run that one more time. Play, stop, crash, and then let's go to our call stack and see where it's crashing. So right here, we're calling the garbage collect. Whoops. And for this, we're calling the garbage collect, but Lua doesn't exist anymore, right? So we can just say, actually, we can just say check to see if it exists first. So if Lua, then do the garbage collect. This could probably just be one line. And that is for the render, and we do the same thing in the update and do the same thing here. So if Lua, do the garbage collect, stop this. It should work if we do this now. I'm not sure if we even need to do the garbage collect anymore, but we'll just leave it there for now. Or we can just comment it out for now. That will do the same for us. Okay, cool. So right now it's saying that it hasn't been loaded. Now I want to see where this is coming from so we can deal with this. This shouldn't be happening. So main Lua script has not been loaded. So let's put that in, and we'll just say main Lua. Hold on. Get rid of the match case right here. So yeah, if it's not loaded, scripting system, we're trying to update the script system, and we're having an error here. And what we could do is, if it's instead of having an error, well, why are we trying to update the scripting system? So where are we updating that? Right now, a scripting system update should be only inside of the scene display. So in scene display update, if we're not playing the scene, it should just return. Okay. So where is our script update? Oh yeah, we have our script system update. So we must still have the script system update in the application. Let's go remove that. Application.cpp. And nope, looks like it's gone. Oh, it's the render. That's why. So we're rendering the script system. Currently, we're not doing really anything for that. So we can actually just comment this out for now. We actually don't need the script system here right now, but we'll just comment it out because if we go to our main.lua, I don't even think we're doing anything in our render function at the moment. So let's just check our scripts. Main.lua, yeah. So gstack.render, but are we doing anything in the gstack? We'll just leave it commented out for now. Okay, then that error should be gone. We'll fix those errors later. There's bigger fish to fry, if you know what I mean. Cool. So now no errors there. We play, we stop, no error. Play. So we got an error here. What is this? Yeah, it's just, that's because we're trying to load the textures. Eventually, we'll actually be loading the textures from the editor, and we won't have to worry about loading the textures in the script until later on. But as we're making a game, we're loading the textures from the scripts rather than the editor because we don't have that capability from the editor yet. Eventually, it'll all be done from the editor for us. But right now, we have to do it from the scripts. So we can just clear that log because it's not really an error. And start the game. And it doesn't, and it's already like, we already had the game started. Clear this and play. Stop and play. Cool. So we're getting some rain. Rain doesn't exist. Snowfall doesn't exist. So it's trying to play sounds right now that aren't existing. But that's fine. But the game is working from the play button. Problem is, we don't know that it's playing and we don't know that it's stopping. So we're going to change this really quick. So it highlights it if it is active at the moment. Okay. So let's go and do that now. So inside of this, we can just stop this here. And let's go to our scene display. And our scene display up here in the draw, so we have our two buttons, right? So before we draw the button, like this is immediate mode. So before we do it, I want to change the color of the button. Okay, so right here we have our image button. But before we call the image button, I want to say, actually, let's do a couple things here. Yeah, we'll say if MB play scene. So if we're playing the scene, we're going to load or push 3 different style colors. So I'm going to go I am GUI, push style color. I'm going to say I am GUI call button, not button, button. And that takes an I am vec4. And it's going to be 0.f, 0.9. So it's going to be more green. And then 0.f, 0.3. So somewhat transparent and somewhat green. Cool. Then the hovered, just copy this. And it's going to be the same. And for active, also, I'm going to keep it the same. Button hovered. For now, we can tweak these later. It's just to show a different color if it's playing. And then button active. Cool. So once these are pushed, we'll play the image, or we'll do the image button for the play texture if it's loaded. And then I'm going to want to check to see if our color stack is greater than 0. We need to pop these colors off. So we go if I am GUI get color stack size is greater than 0. Then we're going to go I am GUI pop style color. Then I'm going to say I am GUI get color stack size. Now, as you see, the get color stack size doesn't exist yet. We're going to create this right now. Now, I can just grab the stack and put it here from I am GUI, but I thought I'll just make a nice little function for that, and we'll use that instead. So let's go here to where it says pop color style, and go to where it's declared. And we'll put this, I'm not sure where a good spot for this would be. We could probably just put it, we'll just put it right here. Actually, right after this. So right here, we'll say I am GUI API, and it's going to be const int, and we're going to say get color stack size. Now there might already be a way to do this. I just haven't found it yet. So we'll just add this in ourselves. Cool. And we'll make this right here. And we'll get rid of this and say const. And then from here, we'll say I am GUI context reference G is equal to the dereference G I am GUI. And then we'll say return G dot color stack dot size. And that should return the size stacked for us. Now the size is an int. Perfect. All right. So now that we have that function, if it's greater than 0, we're going to pop that size off. Okay. And then also, let's add a little tooltip. So we'll say if I am GUI is item hovered. Hovered, I definitely spelled that wrong. Then we'll say I am GUI hovered flags delay, and we'll just say delay normal. Then we're going to want to say I am GUI set tooltip, and it's just going to say play scene. Awesome. So we want to do the exact same thing, however, for not display in the scene. So if we're not displaying the scene, we want to do that for this particular button. So we'll copy this here, and we'll do it right here, and not. And they'll just be the same color. And we'll copy all of this here, and then right after the button, we want to do the same thing. Paste, and then say stop scene. All right, let's run it. All right, cool. See how it's stopped? So it's showing it's green there. We highlight, we stop, play, and we can just hit play, and it came over and it's playing, and we're playing our scene. Awesome. And if we go over here and hit stop, then we can hit play again, and it loads our scene for us. Perfect. It's exactly what we want to see. All right, so that's it for this episode. We can now stop and play the scene as necessary. The good thing about this is previously, in order to show changes that we made in our scripts, we would have to restart the editor and then it would reload our scripts. Now, every time we hit play, it will reload our scripts for us. So any changes that we make in the scripts will be reloaded. Eventually, we're going to be loading the assets from the editor while we're working on the game, and then it'll all be put into a script that will be automatically loaded in the runtime. But that's pretty far out. We're still working on that. We were going to start working on the projectiles, but we'll do that in the next video. Okay, so that's it for this time. If you have any questions or concerns, let me know and I'll make sure to get back to you. All right, please like and subscribe and take it easy.